number of inbuilt types in Haskell which you should definitely be aware of. The first type is Bool. The Bool type refers to a Boolean value. In other words, a value which is either true or false. In this code example, we declare two variables, a and b, which are both of type Bool. Note the shorthand of declaring variables with the same type using a comma, then the double colon, and then the type name. This is just for convenience to avoid having to repeat yourself and define each variable on its own line. As we can see, the variables a and b are bound to the values true and false respectively. The next type is Char. Char is short for character, and a char value represents a Unicode character. Some people pronounce char as car. Either way is fine. In this code example, we declare four variables, d, e, f, and g, to be of type char. Then we bind each of these variables to a different Unicode character. When binding a character to a variable in Haskell, we have to surround it by single quotes, as is done here. This is important. If you use double quotes, you will get an error. Now, I've purposefully used characters from different scripts here to illustrate that Haskell understands Unicode, which is the standard for encoding text in different writing systems. The value of the variable d is from the Latin script, e is from the Devanagari script, which is used for some Indian languages, f is from Cyrillic, which is used for Russian and other languages in Central Asia, and g is a character from Mandarin, which is used in China. If we try to show the values in GHCI, you can see what will be output. Only the value h is displayed properly, and for the others, we get these strange numbers. This is normal. These numbers are the Unicode code points representing the character. GHCI intentionally shows these characters like so, because it does not know whether the command prompt being used can handle the Unicode character. It is better to see these Unicode code points so that you understand that it is a Unicode character than a weird box which tells you nothing, which is what would appear if the terminal didn't understand Unicode. The next two types are int and integer. Let's look at int first. An int is a signed integer with fixed precision. Signed means that the number can have either a positive or negative sign attached to it. This is in contrast to an unsigned int, which has no sign and so can only be positive. Fixed precision means that the value can only be between a specific interval. The actual interval depends on your computer architecture, but the Haskell standard states that an int must be at least 29 bits, so you are guaranteed to have at least 29 bits of fixed precision, but this will vary depending on your machine. You can see the range of values allowed for an int on your computer by referring to the inbuilt max bound and min bound constants. We define the biggest int and smallest int to refer to these constants in our code. And here you can see what these values are by calling them in the GHCI prompt. The biggest int is a huge positive number and the smallest int is a tiny negative number. You can see that for all intents and purposes, int will be sufficient to contain all of the integer values we will probably ever need. The other type is integer. The integer type represents a signed integer with arbitrary precision. Unlike int, which has fixed precision, an integer has arbitrary precision and so is only limited to the memory of your machine. So it can represent both positive and negative numbers, which are far larger and smaller than could be stored in a normal int. In this code example, I've created two variables of type integer called even bigger int and even smaller int. Then I have bound these variables to values which are even bigger than what we saw for the max bound and even smaller than what we saw for the min bound for an int. These are perfectly valid values for an integer, but not for an int. The majority of the time we will just use a plain int because it is sufficient. Another thing to note here is the usage of what is known as camel case to name variables, where apart from the first word, each word which is placed together in the variable name has its first letter capitalized. This is the convention in Haskell. The next type is double. A double is an IEEE double precision floating point number. In other words, a double is a generic way of representing numbers with a decimal point. But remember, a double value has only 64 bits, and so not all decimals are fully representable. There is another type called float, but that has only 32 bits to represent decimals, and so it is not really used. So we will ignore it and prefer double. The next type to consider is a special kind of type. That is, lists. We can declare a list containing items of a specific type and populate that list with a special convenient syntax. We refer to a list using square brackets. For example, the variables j1 and j2 here are both of type list of int. Then we can bind the variable to a value using the special list syntax, which is quite simple. We place the values we want in between the square brackets separated with a comma between each value. So in this case, for j1, we bind the list containing the values 1, 2, 3, 4 and 5, and for j2, we bind the list containing the values 6, 7, 8, 9 and 10. Likewise, you could declare a list of any type, a list of double or a list of bool or whatever, and populate it using this syntax. Lists are really important, and we will look at them in more depth in a later module. For now, we are only covering the basics of lists so we can understand another important type, and that type is string. In Haskell, by default, a string is just a shorthand for a list of characters. I've defined 3 different values here, k, l and m, which we will see are all equal. The first is k, which is defined as having the type of list of char and has the value of a list containing the characters h, e, l, l, o. The next is l, which is defined as having the type of list of char, but we bind the value using this new syntax. Here we place each of the characters next to each other within double quotes. And the last one is m, which is defined as having the type string, and we use the double quotes to bind the same value of hello. As I said before, each of these is the same. The string type is a convenience type representing a list of characters, and rather than having to create a list each time, like we do here with k, we can use double quotes to just create the string directly, like we do with m. We can see that they are equal by inspecting the GHCI output for each variable and seeing that they all output the same thing. Before we move on to the next type, I want to briefly mention a useful operator when it comes to lists, and that is the concatenation operator, denoted by 2 plus signs together. What this does is join 2 lists together and produces a new third list. For example, here with the variable j1 and j2, I am concatenating the 2 lists together. Since the 2 lists j1 and j2 are of type list of int, then the concatenation is also a list of int. We can see that it results in the 2 lists being put together like so. Another example would be if we put k and l together. Since k and l are both lists of char, then the result of their concatenation is also a list of char. But remember that we can just call a list of char a string for shorthand, and so that is what we have done here. And concatenating the 2 strings k and l gives us the string which is just k and l put together. We'll be using the concatenation operator for some of our examples later in this module. The last type I want to cover has another special syntax in Haskell, that is, the type of a tuple. A tuple is a finite sequence of elements. This means, unlike a list, which can have any size, and even potentially be infinite, a tuple always has a fixed size. Also, unlike a list, which can only contain values of a single type, each value of a tuple can be of any type. Let's look at some example code. Here, we are declaring a tuple with 2 elements, with the first element being an int and the second being a double. Since there are 2 items in the tuple, we call it a 2-tuple or a pair. Now let's consider this tuple. There are 3 items in the tuple, so we call it a 3-tuple or a triplet. The first item is a string, the second is an int, and the third is a character. You can see the syntax for tuples is quite simple. In the type signature, the tuple is defined by placing a comma-separated list of the types of the tuple's elements within brackets. Then you provide a binding of values for the tuple by doing the same thing, but replacing the types with values. What is the biggest number of elements you can have in a tuple? Well, according to the Haskell standard, every implementation must support tuples with up to 15 elements, so we can happily create anything up to a 15 tuple if we need to. There is a special type of tuple, the 0 tuple, which is called unit in Haskell, or sometimes the empty tuple. There is only one valid value for a tuple of type unit, and that is the empty tuple itself, represented in the same way the type is, as an empty pair of brackets. If you are familiar with other programming languages, you can think of it kind of like the type void in C or Java. This type is not important for beginners. It will become important as you start to understand intermediate and advanced concepts. I'm just mentioning it here so that you are aware it exists. A word of caution on tuples. In Haskell, it is not considered good practice to use tuples which are large in size. Occasionally, using a pair or a triplet is fine, but anything other than that should probably be avoided. This is because Haskell gives you better options for modeling your types, which can be used instead. We'll cover these in later sections. There are a number of built-in types in Haskell which I have not covered, but I've covered the most important built-in types here, and we will build upon this foundational knowledge throughout the course. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Learn channel. See you next time.